MacuHealth is a nutritional supplement leader. Our targeted formulas include MacuHealth for daily eye health, MacuHealth Plus for aging eye support, Vitreous Health for vitreous care, Vision Edge Pro for visual performance in athletes, TG Omega-3 for ocular and systemic wellness, and MacuHealth DM for eye and metabolic support. Call MacuHealth today and mention this podcast for special discounts. Experience the difference with MacuHealth. Nutrition you can see.
With more screen usage and indoor time, myopia, also known as nearsightedness, is increasing and getting worse in children. Now, certified eye doctors can prescribe MySight One Day, the first and only FDA-approved soft contact lens to slow myopia progression in age-appropriate children. Visit CooperVision.com to find a Brilliant Futures certified eye doctor near you. Do your patients know what presbyopia is?
There are people who are afraid of the press.
Have you talked to your patients about multifocal contact lenses?
I've heard the bifocal, but not multifocal.
Exactly, not multifocal.
Do you need help with your multifocal strategy? Learn more at the conclusion of this episode. Hello and welcome to the Dr. Kerry Gelb Open Your Eyes podcast. I'm Dr. Kerry Gelb, host of the Open Your Eyes documentary. If you're new here and you enjoy our interviews, press like, subscribe, share, and hit the bell for updates on new episodes. Great news, our full-length documentary is now streaming on Amazon Prime, Apple TV, iTunes, Google Play, and YouTube Movies and Shows. And visit my new website, wellness1280.com, for all guest links, resources, and past episodes. And I'd love to hear from you, so reach out to me anytime at drkerrygelb@gmail.com. That's drkerrygelb@gmail.com. So please sit back and enjoy my conversation with nutrition researcher, Dr. Jim Stringham. Each year, about 2.8 million Americans sustain a traumatic brain injury, leading to nearly 69,000 deaths and leaving 5.3 million people living with TBI-related disabilities. These injuries are notoriously difficult to treat because the brain doesn't heal like other tissues. But new research offers hope. Studies show that macular carotenoid nutrients and omega-3s, EPA, DHA, may play an important, powerful role in protecting the brain and even improving recovery from TBI, concussion, and CTE. A recent Penn State rugby study found that a supplement containing carotenoids and omega-3s was protective, even in young athletes. To help us break this down is today's guest, experimental psychologist Dr. Jim Stringham, PhD. He completed his postdoctoral scientific training at Harvard Medical School and the Medical College of Georgia, and is now the Chief Scientific Officer at Macular. Dr. Stringham's research explores how nutrition can enhance visual and cognitive performance in athletes, improving systemic health in those with metabolic disease, and support neural development in children. Jim, welcome to the Open Your Eyes podcast with Dr. Kerry Gelb.
All right. Thanks, Kerry. I appreciate it.
So listen, Jim, I'm very interested. I've been following your work for a long time. I have a son who's an avid baseball player, and I've been giving him this supplement that you know about, that you work with the company Macular, and he really could hit the ball very, very well. And he had kids on his team that were striking out and swinging and missing. And when they started taking this supplement of meso-zeaxanthin, zeaxanthin, and lutein, they started hitting much, much better. And I want to talk about that after we talk about CTE. So let's start off with CTE. What is CTE and how is it diagnosed?
Well, yeah, so CTE is an abbreviation for chronic traumatic encephalopathy. And, most folks have probably heard this in the news, if not related to football, related to some pretty harrowing incidents where they suspect that, folks that are doing, pretty nefarious things, gunmen, etc., may have had, brain damage effectively caused by repeated head injuries brought on by, say, for instance, playing football. And CTE is a neurodegenerative condition, and it's generally brought on by subconcussive impacts. So you're not necessarily being diagnosed with a concussion or a TBI. These are milder, but nevertheless, pretty severe. And what ends up happening, I mean, if you're familiar at all with the sort of physical structure of the brain, you know that it has these folds on the top, the sulci, they're little ridges, and the convolutions of the outer portion of the brain. And so what we see with that shape is that they go in and they have these little dips, a little sort of, I guess you could say, little miniature canyon shape. When you jostle the brain, say just getting tackled in football, you go down and kind of, you don't necessarily smack your head too hard, but it jostles it. You're maybe a lineman in football, and you're getting some sort of impact there on nearly every play. You're shaking the brain a little bit, and those convolutions, the dips in there, just due to their physical structure, they receive a pretty good shearing force. And so that makes things move around. It pulls around the blood vessels that are feeding those areas. And again, the brain is highly vascularized. You need a lot of nutrients. You need oxygen getting to these tissues that enable us to do what we're doing right now, having, an in-depth conversation about this. And so you've got these blood vessels, and the tissue, the brain tissue, kind of gets sheared. It gets shorn away from the blood vessel. That causes an inflammatory reaction, and over time, repetitive head, sort of jostling, this subconcussive, these impacts, that causes, proteins like tau, and we hear about in Alzheimer's disease, neurofibrillary tangles. That involves what's called p-tau, or phosphorylated tau. And anyway, these tangles start to happen over time with all of these repetitive, head injuries. Again, minor, but additive. And so you don't give the brain a chance to heal. This compounds the situation and makes it worse. And that's a long way of describing what CTE is, but ultimately, this happens in a lot of areas of the brain. Of note, the limbic system, which, is involved in aggression, in mood, sort of emotion. And so we're talking about the amygdala, if folks are, familiar with that, memory, aggression, inhibition of emotional, outbursts, that kind of thing get affected. So it's a big deal. And we know that, the longer you play contact sports, the higher your chance of developing CTE is, to the point where 99% of players, former NFL players, pro level, football players that have had their brains examined have diagnosed CTE. So it's very scary. I mean, it's a very prevalent thing.
And can you diagnose CTE when you're alive, or does it have to be done on autopsy?
It really is autopsy. So you've got to see, afterwards to be able to image these, really find, the neurofibrillary tangles. You can, infer from behavior, just similarly as you would with Alzheimer's disease. You can infer, what's going on, certainly. And there are changes, major changes in personality. The family members, are often alarmed at some of these major changes, particularly anger, mood disturbances, those kinds of things.
And what are the symptoms? Brain fog, there's aggression, depression. What are from doing this type of work, what are some of the main symptoms that you notice other than the ones that you might have mentioned already?
Well, it's not a study. It's not my area necessarily of expertise, but the main symptoms that you hear about from other researchers I've talked with in the area, it starts often with forgetfulness. So there's again this the limbic system in the brain, mood and memory, aggression, these kinds of things. Anxiety often crops up. So you see, what you might describe as an anxiety disorder often comes kind of early. And then, memory disturbances. And then most notable are the mood disturbances that typically take place, and they usually involve aggression, anger, and so these are the major changes where you'll have a person go from being kind of an affable, lighthearted person, turning into what people would describe as kind of a monster, and so it's a dramatic change, and it's the inability to inhibit these kinds of aggressive feelings.
And every year someone plays football, I saw a study that about 15% increased risk of getting CTE. What does that mean to kids that are playing football, that maybe their skulls aren't developed, pee-wees playing and their skulls aren't developed? Even, as you mentioned, every single football player that has had an autopsy has had CTE. So what does that mean to our children that are playing?
Yeah, this worries me. I mean, I'm a huge sports fan, and I love football. I played for a couple of years, when I was younger, and it scares the crap out of me. I think about kids, the developing brain. Certainly, you don't want that repetitive jostling. When you're under neural development, forming new tracks and synapses and all of this. You can, as you can imagine, it would compromise development. Which we don't want to do early on. And really the takeaway in terms of, playing contact sports regularly, like football, for example. I mean, we have others, there's risk in, lacrosse and rugby, certainly, ice hockey, all of the sports where you've got, potential for, these impacts. The takeaway really is that the longer you play, the more severe the CTE. I mean, it's clear-cut data. A lot of this work was done by a Professor Anne McKee at Boston University, and she and her group have characterized this, cumulative damage idea. And I believe it's something like every year you play raises your chance of diagnosis of CTE, and this is for football, by 9%. So, you just do the math, and gosh, if you're playing, in Pop Warner, early Pee Wee League football, and then into high school, say you're pretty good and you make it into college, you're talking about 8, 10, 12 years, maybe 15 or 20 if you make it into the pros. Now that's a pretty, small number of folks that do, but still, even for somebody who, plays in high school and college, you're looking at least 10 or 12 years, and then we have evidence from brains of folks that, have just played in college a couple of years, and it can be severe depending on, what position you play, how many of these subconcussive impacts that you sustain.
And there's that study in Annals of Neurology, the 2023 study, that if you played 15 or more years, you have up to a 95% chance of having CTE. So I have to ask you this question. I hate to ask it to you, but I'm going to ask it to you. If you had a son that wanted to play football, knowing what you know, would you let him?
Yeah, this is a really tough question because, like I mentioned, as a kid, I love the sport of it, but I would, frankly, between you and me, just knowing what I know now, I would have to, limit that. I'd have to say, let's go somewhere else. Let's go to a different sport. It's a tough one, but again, just seeing the data, and there was another study out of Anne McKee's lab that characterized young individuals that had largely died by suicide, and their brains were examined, and the youngest person in that study, they averaged, by the way, I think in their 20s. So this is not a disease that you just diagnose or you sort of get, quote unquote, in your late in life. The youngest was a female soccer player, 17 years old. And so, again, when you think about soccer, you think, well, jostling of the head. Well, it's, sort of the heading the ball. The brain is, even the sort of the skull is undeveloped at that point. And so it's a little softer. You're sustaining more damage potentially with, heading the soccer ball. Those can be pretty severe impacts. And so That was what was thought to lead to that CTE development in that child. So yeah, to answer your question straight up, I don't think I could let my son or daughter, as it may be, play football, tackle football. That's rough. I do have three daughters, so I didn't have to face that, as it turns out, but lucky, I suppose.
How about boxing and wrestling?
So, it's interesting. CTE is something that we've heard come up recently, fairly recently. The first official diagnosed case was back in the 1990s, I believe, and it was Mike Webster of the Hall of Fame Center for the Pittsburgh Steelers, a professional football player. And so this is where the term was coined, chronic traumatic encephalopathy. But it goes back, really, the same kind of thing was noted in boxers back in the early 1900s, called dementia pugilistica. So, you get dementia from boxing. And really, that is probably the most solid model for CTE, where you have many subconcussive impacts. I mean, you're getting punched, presumably a lot. If you're really good, maybe not as many, but nevertheless, you're getting sustained blows directly to the head, some worse than others. But yeah, that's really where it was first noted. These symptoms of anger, uncontrolled rage, inability to control emotions, major personality changes.
How about back to football linemen? Every play they're hitting each other, probably 20, 30 Gs. Talk to me about the Gs. How much do you need to really get damaged, to be knocked out?
Yeah, so I mean, these G forces, and again, the force of gravity is at 9.8 meters per second, so it's a pretty good, solid, like 15 miles an hour bonking your head against the wall. It's common in football to sustain 15, 20 Gs, so you're really smacking your head pretty good, potentially, or the body when you're, for instance, getting tackled. These linemen, on nearly every play, of course, the way, the format of football, where you're sort of in a 3-point stance, you're leaning down, you're going to meet heads in many cases with the opposing lineman. And so nearly every play, a lineman sustains, some sort of impact. And now that impact might not be as dramatic as, say, when a wide receiver catches the ball and then the opposing defensive back is flying at him, running 15, 20 miles an hour and then rams into him. But nevertheless, this repetitive impact has a huge impact and the, impact on the development of CTE. Initially when folks were speculating about positions, they thought, well, linemen might not be as susceptible because it doesn't appear there's not as great an impact. However, it's interesting, of course, I mentioned Mike Webster, the first, case of CTE. He was a center. He was a lineman. There have been many cases where, and I think, I've sent you some images of a lineman at the University of Texas, dramatic CTE, and that's, just in college. So I think that really the point here is not that it's associated with the dramatic, big diagnosed concussions, because think about this, Carrie. If you get diagnosed with a concussion, whether it's from a car accident or in a football game, you are ordered to rest. You have to stay out for a while, and you have to pass, pretty stringent neurological tests to be able to get back to normal life, or certainly get back on the playing field. So you're allowing the brain to heal, and the brain can heal. It actually does a really good job of it if you let it heal. So when you're not diagnosed with a concussion, what ends up happening? Well, you just go about life as normal. And on the football field, for instance, it's, you're going back on the playing field. And so even though there's a minor injury, you're not necessarily aware of it, or you think, well, that wasn't too bad. I can get back out there and play. And players want to get back onto the field and play. So you do that over and over and over again. you're not allowing the brain to heal, and then you get this cumulative damage happening that results in these tangles and decay in key structures in the brain.
It's very, very, very interesting. And I think a G-force of 60 to 90 can knock somebody out.
Yeah, that's right. Yeah, 60 to 90. And you see that it's not uncommon in football games, and even over 100 can happen. It's crazy. And often that results in a worse outcome for the defensive player hitting the offensive player, because usually the defender is not necessarily leading with the head, but the head is involved in the impact. And so, yeah, it's kind of astonishing the kinds of G-forces. I mean, if you can imagine running full speed into a brick wall, I mean, it's kind of akin to that with your head, so that can't be good, certainly. And, we know now we have brain imaging, we have, actual, sort of data on this, and it looks bad, and it is really bad.
Is there any data that you're aware of that how many times you get knocked out, whether if you got hit in the back of the head with a baseball or boxing and you got knocked out, that it takes to affect your brain a little bit?
Well, it's from my scouring of the literature, and talking with some researchers like Anne McKee or neurologists, it's all about allowing the brain to recover. So if you have one concussion, let's say, if you allow the brain to recover, typically you don't see long-term effects. Typically, there are some studies suggesting that even one serious concussion can be mildly associated with developing things like Parkinson's disease or Alzheimer's disease, but generally speaking, you allow the brain to heal, you're going to be okay. It's when you start seeing multiple concussions, and again, 2 or 3 or 4, we know of these quarterbacks, for instance, probably most famously Tom Brady. He's had many concussions. I believe it's at a dozen or more. Of course, he lets those things heal. He takes very good care of himself, including a diet, and we can obviously get into the dietary, the nutrition component of this, but that allows or helps the brain to heal. And it's based on the data. It's my contention that as long as you're really trying to let the brain heal, allowing it to heal, you're not forcing more inflammation, more oxidative stress there, then you're not necessarily going to see the long-term effects, negative effects. It's when we have this repetitive cumulative damage where we start to see major problems. It's not to say that getting 12 concussions is good for you. Not at all. And there may be long-term effects, certainly. And I know that the more that you sustain concussions or TBIs, the greater chance there is of long-term problems like, say, Parkinson's disease or dementias like Alzheimer's.
So if you do get knocked out, does that automatically mean that you have a TBI or a concussion if you black out?
Yeah. Typically, that's what we associate with it. If you get knocked out, that's almost always associated with the TBI. There are cases where you're blacked out, and then neurologically under testing, you don't show signs. You don't have the classic light sensitivity, vertigo, things like that. Pretty rare. But generally speaking, yeah, if you get sort of knocked out, quote unquote, you've sustained a concussion or TBI.
So I think maybe we should explain the difference between CTE, TBI, concussion. If you could explain the difference between those.
Yes, primarily severity. I mean, CTE is not. It doesn't describe the physical act. CTE is the neurological result of typically subconcussive impacts, repetitive head impacts. Concussion or traumatic brain injury. These are, major events. They don't describe the neural, sort of the pathology that results. This is more about, the actual experience, the both the trauma and then the symptom outcome. So, in other words, dizziness, vertigo, lightheadedness, migraine, headache, light sensitivity, these kinds of things that are associated with those major impacts. So hopefully that makes sense. The CTE is more or less the description of the pathology in the brain.
We're up against a break, but don't go anywhere. We'll be right back with Dr. Jim Stringham.
MacuHealth, your science-born and tested solutions for visual performance, macular degeneration, and dry eye syndrome. New products coming soon. Embrace the science.
And there's been other famous football players that have donated their brain to science, as like Junior Seau, Dave Durson, and the story of Dave Durson. Can you talk about that?
Yeah, so Dave Durson, I'm familiar with a few of these stories, but I do know that, like in the case of Junior Seau, I believe Durson was the same, where, he changed dramatically. I mean, he was of course, I'm not sure if he's in the Hall of Fame, but he was an all-star. He was a very good defensive back for the Chicago Bears. And in his late 30s and early 40s, things changed pretty dramatically. He ended his own life, but he was careful, just like Junior Seau, the linebacker for the San Diego Chargers at the time in San Diego. He ended his life careful not to shoot himself in the head, but rather in the chest, wanting in a letter to his family to get his brain examined, because he suspected that football had changed his brain in such a way as to cause his major personality change, and aggressiveness and all of that. And so, you fast forward to the analysis of the brain, and indeed, they find, massive damage, decay in these areas, again, that are responsible for, emotional, sort of inhibition, aggression, anxiety, these kinds of things. And it's, literally, you can see the brain under examination, just visual examination, it's black in those areas. Whereas it should look otherwise like, fresh, sort of light colored tissue, it's completely decayed, and it looks like it's rotting. And so, that's the story with Dave Durson. I know Junior Seau was similar. Ken Stabler, the Hall of Fame quarterback for the Oakland Raiders, famously, again, he didn't take his own life, but he wanted, after he died, to have his brain examined. And same thing, he said, "Wow, there are major changes. I want to know what's going on. My family needs to know. People need to know." And you look at Ken Stabler's brain, and they're the signature tangles, the decay, all of that. And again, he was a quarterback back in college for Alabama, and so he played a long career. I think probably 15 years at least in the pros. And so again, cumulative damage brought this on.
And you touched on it a little bit about the pathology of CTE. Can you explain a little bit about the neurons, the astrocytes, what happens about the tau losing the tubule connection and it kind of shriveling up and becoming these little these little spots that are, these tubules that are no longer working?
Yeah, absolutely. Well, it's really about a cascade of inflammation. And this happens with any kind of, head impact, any kind of, even minor brain injury. There's an immune alert that goes off. And so things are recruited. And depending on how serious the injury is, I mean, in the case of an actual, a traumatic brain injury, a concussion, you may have the blood-brain barrier may be breached. And this is a scary situation because that barrier is in place. I mean, these are glial cells that form this net, a very tight net that only allows certain things in and keep things out, and maintain and keep things in as well. So you get not only the immune system kind of panicking and upregulating inflammation, because that's what the first line of defense in the body is in the immune system's case is inflammation. It's raising these pro-inflammatory cytokines. Maybe you've heard of IL-6, tumor necrosis factor alpha, IL-1 beta, these kinds of things. There are a suite of these that they get upregulated. You find pro-inflammatory cytokines in the brain that you wouldn't normally find in the brain, like IL-6, a very common pro-inflammatory cytokine. If the blood-brain barrier is broken, it can get in and do cause problems. Again, the immune system, we think of the immune system as helping us, and in most cases, of course, it does, and we need inflammation in many cases, but usually at lower levels and for shorter time periods. What we're talking about with the TBI, or in the case of CTE, is this upregulation. These glial cells, kind of signal to undifferentiated cells to turn into these phagocytes, and they trigger inflammation. They're recruiting inflammatory, damage-associated molecular proteins that get upregulated, and they're feeding into this, and oxidative stress comes into play as well. And it's interesting, these feedback loops that happen. The immune system uses oxygen. It uses free radical oxygen to kill things. And sometimes that's good, but in this case, you don't want that in the brain. And so you've injured the brain over and over and over again. You set up these feedback loops. Oxidative stress causes inflammation, and then inflammation, the immune system brings on more oxidative stress, and that brings on more inflammation, and it's a cycle. And so in a general sense, that's what's going on in the brain. It's very difficult to resolve these cycles, and this is why often you see symptoms of concussion and TBI lasting for so long, sometimes for years, depending on the severity. And certainly in the case of CTE, it's a little more drawn out, where the injury is happening and then finally it manifests as disease, behaviorally, symptomatically. So it's all about really inflammation, and oxidation plays a big role there as well.
It's interesting how the tau accumulates in the neurons and the astrocytes, and the astrocytes actually regulate the blood-brain barrier. So that opens up, and that really, when that opens up, that's a recipe for disaster.
Yeah, that's right. And it's interesting about tau. We hear tau now, and the tangled tau, and how that's associated with Alzheimer's disease, and here with CTE as well. But tau is actually protective on its own. Tau is actually a good thing, and it actually helps to heal in the brain. It's when it gets twisted and tangled, and this is called phosphorylation. And so when that happens, and this is due to interaction, with inflammatory proteins, that's when things go wrong, and that's when you start getting this decay, the degeneration associated with CTE, and certainly Alzheimer's disease as well. That's where you start getting the shrinkage of the brain. The tissues are actually degenerating, and you also get this this awful looking, the black, sort of decayed tissue pathology that's sort of symptomatic of CTE.
Let's talk about the role of nutrition and how it could be protective. First, give us a little background about carotenoids, what they are, where they're located in the body. And, at one time, I don't think we knew they were in the brain. Now we know they're in the brain, and the eye is the brain. So talk to us a little bit about that.
Sure, yeah. So carotenoids are a class of pigments they're plant pigments. So you think of the colors, fruits and vegetables, leafy greens. You've got carotenoids in pretty much any kind of colored fruit or vegetable. We think of tomatoes, and that's lycopene. Beta carotene is a plant pigment as well, the orange one. Lutein, zeaxanthin, those are found in leafy greens, dark leafy greens like spinach, kale, these kinds of foods. And then, where they go in the body is very interesting. And carotenoids are pretty fascinating as nutrients. And of course, we in the developed world don't eat enough of these colored fruits and vegetables, dark leafy greens to get enough in our body. But when you look at where they go in the body, you'll want to start eating more carotenoids because what they do, they're powerful antioxidants. They can, disarm free radicals. We talked a little bit earlier about the role of oxidation in CTE. Certainly, these oxidative processes have, negative effects all over the body. The eye, the retina, the brain, certainly. And so they're extremely powerful antioxidants. They accumulate in specific tissues. That's really, sort of characteristic of carotenoids, any carotenoid. So for instance, lycopene in tomatoes, the red pigment, that happens to accumulate, if you're male, it accumulates in the prostate in high amounts. And so, and it's thought to offer, well, actually it's been characterized to offer, very beneficial effects there. In terms of neural tissue, the body prefers these specific xanthophyll carotenoids, and they're long chain, lutein, zeaxanthin, meso-zeaxanthin is another. They accumulate in the retina, the foveal retina, in very high amounts, associated with reduced risk for developing macular degeneration, a major neurodegenerative, eye condition, leading cause of blindness in those over 60 in the U.S., for instance. They also accumulate in the brain. The brain really loves lutein, to a lesser extent zeaxanthin, but we found this out in 2004 that it makes it to the brain at all, and then in 2013 some of the specific areas where lutein particularly is accumulating. And what's fascinating about where these nutrients go, they go to, and this includes the retina as well, they go to areas that require, really high metabolic rate. So we're talking about oxygen coming into this neural tissue. The body's not stupid. It puts antioxidants in the place where oxygen can go wrong. It can go, radical. It can become, singlet oxygen and damage tissues, like the retina or the brain. So with regard to the brain, specific areas, I mentioned the limbic system being involved in CTE earlier. Well, you find lutein accumulating there. Frontal cortex, prefrontal, right behind the forehead there. Occipital lobe in the back. These are areas that are affected by CTE. And so it's interesting that you've got this potential protection against the oxidation and ultimately the inflammation offered by carotenoids in these areas. And so, this kind of forms the basis for, a targeted nutrition intervention potentially, or at least potentially some help for those in a situation like football, where you might, be under duress in the brain and potentially develop CTE.
I think it's interesting that it also accumulates in the auditory.
Yep. Oh yeah, auditory cortex. Yeah, for sure.
So can carotenoids help hearing?
Yeah, there are studies out that suggest that, hearing thresholds are affected by, carotenoid amount. And particularly, again, lutein is the one in the auditory cortex. These carotenoids help systemically as well. They're, found throughout the body. So if you were to take, lutein, zeaxanthin, meso-zeaxanthin, which we know are the only 3 carotenoids that make it to the macular retina, folks, even eye doctors, some of them think, well, you take this supplement and it just goes from your mouth to the eye. And in fact, That's not how it happens. Of course, just like any other nutrient we consume, we digest, passes through the intestinal wall and then it's systemic. And so you get, deposition in tissues like the skin, cardiovascular tissue, certainly the eyes and brain. But we're seeing, potentially there are systemic effects as well, just maintaining, a reasonable level of inflammation, lower levels of inflammation systemically that can help with things like hearing, we see reduced brain fog, that kind of stuff that is known to be impacted by inflammation. So keeping levels high in your system, consistently consuming foods or supplements that contain these nutrients is key.
I mean, you're one of the top researchers in this area in the whole world. I mean, before we start talking about the CTE part, how about glare, photophobia, being sensitive to light, going from light to dark, contrast? You did some of these studies. Tell us about how the carotenoids could help that and which ones help in those areas.
Yeah, no, I'm happy you asked about that. So early in my career, this would be the late 1990s, early 2000s. Of course, the big story around carotenoids was the AREDS study, and this, showed, and we had other evidence outside of AREDS as well, showing reduced risk for developing macular degeneration. And so it's a great thing. It's very great. And so we've known about that really since about 1994, this suggested correlation between, diet rich in leafy greens and reduced risk for developing macular degeneration. If you're able to consistently over your lifespan have, high levels in your body, great outcomes. And not just for macular degeneration, but that was the story. And I thought, well, we're talking about these nutrients that are, late in life having effects. But we see lutein, for instance, in breast milk. Really early in life, we're supposed to be getting that. There's got to be other effects. And certainly by now we know, developmental benefits, neonatal, sort of even in the womb, going back to the beginning of life. All the focus was on the end of life. And I thought, well, yeah, evolution wouldn't, select for something that prevented an age-related disease, after you're 65, let's say. It's got to have other benefits. And so I thought, well, maybe we're talking about visual performance. There could be a relationship there. And I, was born and raised in Arizona, that's sort of the Phoenix area. And of course, we have a lot of bright sunlight. A lot of people struggle with bright lights. And so, obviously sunglasses are great, to wear outside. You want to protect your lens and your eyes and all of that, retina included. But, the glare, people squinting, looking away. My advisor at the University of New Hampshire, where I went to graduate school, Ken Fold, he suggested, well, let's look at photophobia, sort of visual discomfort and macular pigment level and see what we see there. And so just almost on a whim, I mean, this is a graduate student, project. We looked at this and using really strong lights of various color, including, sort of through the spectrum, Roy G. Biv, and found that discomfort from light was produced most prominently by short wave light, by blue light. And that was interesting. And so we thought, well, that's different than normal visual sensitivity, which we're most sensitive really to green, the middle of the spectrum. So blue was really driving it. Now, something about blue light is interesting. It has higher energy. As you go shorter into the deeper blues and violets, you get higher energy light, has more potential to do damage to the retina. So it's interesting that you would have more discomfort. You'd want to look away from that shortwave blue light because it has more potential to do damage to the retina. So it's a kind of a brilliant thing, right? That the visual system's set up that way. Something interesting about macular pigment, of course, is it's yellow. It gets deposited in the retina. It's, lies in front of the photoreceptors. And so it shields, it acts as a yellow filter, and yellow will filter this shortwave light. So it's a nice situation where if you have higher macular pigment, higher density of these carotenoids in the retina, you are getting, more protection from this shortwave, potentially damaging light, but you're also able to maintain, visual, sort of engagement with your visual task before having to look away, having to squint out of discomfort. And so that's pretty cool. So that was the very first study that I did personally, was this visual discomfort. That, fast forward a couple of years, we started looking at things like, glare. And glare can certainly cause discomfort, but in many cases, it's just bright light and you can't see through it, right? It kind of washes out your vision. You can think of driving at night, oncoming headlights, these kinds of things. We found that individuals with high levels of macular pigment could see through the glare and maintain, visibility of the target, which was really cool. You can think of all of the areas that might help. Certainly oncoming headlights from cars driving at night, but also in sports. Sun field in baseball, you're looking up, you've got, bright light from the sun, from stadium lights, these kinds of things. But just you and me driving down the road, there's a lot of situations where we lose contrast greatly from bright lights. If you can defeat that bright light and see through, which macular pigment densities that are very high afford that capability, you're at a distinct advantage. So the glare is one thing, discomfort is another. Speed of visual processing is enhanced, so you're able to speed up, take more snapshots per second of the visual field. It's really, really cool. That's a killer combination, having enhanced contrast sensitivity, which we also see with high levels of macular pigment, and speed of processing. That's the killer combo. Certainly, I mean, in life, but as an athlete, amazing. We found this doing some work when I was with the Air Force Research Laboratory in San Antonio in Texas. And that, as you can imagine, military operations, high performance military personnel value very good visual performance. And so one way to get that is through, nutritional modification, supplementation with these macular carotenoids. And so, lastly, I think I need to mention that you get enhanced visual performance in low light conditions. We've talked about bright light, causing discomfort, glare, but low light as well. So you're expanding the range of, the dynamic visual range from low light way into bright light. You're able to function. And that's one of the first things that folks will note. Driving at night, just, seeing in low light is greatly enhanced by these carotenoids in the retina.
I can tell you clinically from using supplements with lutein, zeaxanthin, meso-zeaxanthin, that patients do very well in low light. They do much better with glare, with photophobia, not only prescribing it as a decreased risk for macular degeneration, but just general visual performance. And in sports, which we'll talk about a little later, I did want, before we go back to the brain, this is so interesting, I did want to ask you about eye strain on the computer. I think you were involved in a study with that, and I noticed patients do much better on the computer when they're supplemented or they're eating foods that are high in carotenoids.
That's very true. 2017, we published. I was at the University of Georgia at the time. We published a double-blind, placebo-controlled trial. And college students, they're on screens all the time, whether it's computer, tablet, phone, and even in young individuals are complaining about eye fatigue, eye strain, and this lack of sleep. There's all sorts of concerns with screens, and it's interesting because you think blue light, coming from a screen. You hear about this blue light; it's a real buzz term. The sun puts off a lot more blue light than a computer screen. And so, our daily dose of blue light probably in most individuals comes from the sun. However, it's interesting to note that a computer screen, to make a white color sort of a background on a Word document or whatever, a nice rich white color, you mix a blue phosphor with yellow. And it's not like paint where blue and yellow make green. With lights, blue and yellow kind of cancel each other and make a nice white. And that rich white color comes from a little more blue. You add a little more blue to it. So believe it or not, yellow and blue make white on a computer screen. So you are getting that, daily sort of that dose, and depending on how much you're in front of a screen, you're getting a lot potentially of blue light. And it's not enough to cause discomfort necessarily acutely. It's not enough to cause, some sort of fatigue right away. But you think about the mechanisms that blue light can set off. And we showed squinting of the eyes in our photophobia study that was really brought on pretty easily by blue light exposure. And granted, it was brighter. But if you look at somebody on a computer screen, they will eventually start to just squint a little bit. This low-level squinting can lead to, headaches, eye fatigue, and eye strain. And again, this isn't caused, at least in our population, with young college students, 18 to 25. It wasn't an accommodative issue. We're not talking about presbyopes here, where you're squinting because you're trying to focus. It was most likely this exposure to low-level blue light. And so this is what I believe led to the experience that what we found in the study was a significant reduction in eye fatigue, eye strain, and frequency of headaches. So all of these things are kind of connected, and we didn't see that in the placebo group. They stayed relatively flat throughout the 6-month supplementation trial. And at 6 months, we saw these kinds of effects in the treatment group, those that received the lutein, zeaxanthin, and meso-zeaxanthin. It's pretty fascinating. And I got to tell you, we didn't know what to expect when we undertook the study. I wasn't sure we'd find anything, but it was pretty clear cut at the end.
For the listeners that don't know about this, what is the macular pigment, and having a thick macular pigment, does that decrease your risk of the number one cause of blindness over the age of 55, macular degeneration?
Yeah, so macular pigment, we measure the optical density of it, and that simply means how much light it filters. Now, specifically, like I mentioned earlier, the macular pigment filters this blue light, the short wavelengths, over about 400 nanometers up to around 520, 530. So from a deep blue to a blue green. And so we can measure this in a few different ways, but suffice it to say, the more consistently you're ingesting, colored fruits and vegetables, particularly dark leafy greens, spinach, kale, and some other foods that contain obviously lutein and zeaxanthin, you're going to see the macular pigment get built up. Now, as you might imagine, there are many individuals, in fact, most in the US, don't get enough of these kinds of foods, nor do they supplement. And so we see averages very low in terms of this density. And you can change that. We do supplementation trials. I've talked about a few of them here. We measure macular pigment along the way as well. And the density of this, and you can imagine it kind of like sunglasses. So, average sunglasses, pair of Ray-Bans, it has a 0.5 optical density. And so, again, Ray-Bans typically are kind of a charcoal color. They block across the visible spectrum. They don't appear yellow, at least not typically. And so they're blocking, a lot of the light. They have an optical density of about 0.5. Now, optical density is on a logarithmic scale. So the math dictates that if you change by 0.3, you're doubling the density. So you're doubling the light filtration capability of in this case, the lens. So if you were to go from 0.5 to 0.8, you're doubling the absorption of light. 0.8 to 1.1, you're doubling over again. So it's kind of an exponential increase, right? 1.1 to 1.4, a change in 0.3, so on and so forth. And so in terms of macular pigment, how high can you go? And this, it tells us, I think it teaches us an important lesson. it can go astronomically high. It can go, I've measured people above 1.5 optical density of macular pigment. So the capacity for the retina is very huge. And so I've measured people again above 1.5. Folks, above one log unit of macular pigment is very high. National average in the United States is 0.3. I've measured people with none, with 0. And, you ask them, have you ever eaten a vegetable before in your life? And with a straight face, they'll say, nope, I avoid everything. I take the iceberg lettuce off my hamburger, which iceberg lettuce isn't going to do a lot for you, but it's interesting to see. And so to get to your question about macular degeneration, life is a long game. And so we saw first in 1994 with Johanna Seddon out of Harvard, her study that showed that folks, over the age of 65, that, you look at their life epidemiologically, what they've done, exercise, diet, and so consistently over time, if they had, diets rich in leafy greens, specifically, it looks like lutein and zeaxanthin, which of course are major components of the macular pigment. If you've got those nutrients in your diet consistently over time, the decades of life, you greatly reduce a nearly 50% reduction in risk for development of macular degeneration. This idea was replicated again in 2011, virtually the same finding, 46% reduced risk. So yes, the caveat here is that it's cumulative damage. It's over time. So the earlier you can start, you can build up this macular pigment, the better. You mentioned, I think your son who plays baseball, he's got a great head start here because, presumably his macular pigment is quite high. He's been taking these nutrients in, a couple bowls of spinach worth every day, presumably for a long time. And so I would imagine if I were to measure his macular pigment, it'd be very high.
We tested hundreds of kids, and he was the highest.
No kidding. That's amazing. That's so great. And, I mentioned I've got 3 daughters. All 3 of them are off the charts. As you might imagine, we make sure that they eat well and supplement. And so we're getting, they're set up for success. And so, you start early. It's not to say it's ever really too late. We do see effects late in life with supplementation. Even in those with early macular degeneration, you can, slow down the progression. Evidence certainly for that, based on, sort of disappearing drusen, these markers for AMD. It's important though, I think, just, the long-term, proactive preventative approach is really the key here. And, the earlier you can get these nutrients in and more often, the better.
That's a wrap on part 1 with Dr. Jim Stringham. And that's just the beginning. In part 2, we explore how carotenoids don't just protect your vision, but sharpen your reaction time, help you hit a baseball, and give you an edge on the tennis court. You won't want to miss it, so stay tuned.
MacuHealth is a nutritional supplement leader. Our targeted formulas include MacuHealth for daily eye health, MacuHealth Plus for aging eye support, Vitreous Health for vitreous care, Vision Edge Pro for visual performance in athletes, TG Omega-3 for ocular and systemic wellness, and MacuHealth DM for eye and metabolic support. Call MacuHealth today and mention this podcast for special discounts. Experience the difference with MacuHealth. Nutrition you can see.
With more screen usage and indoor time, myopia, also known as nearsightedness, is increasing and getting worse in children. Now, certified eye doctors can prescribe MiSight One Day, the first and only FDA-approved soft contact lens to slow myopia progression in age-appropriate children. Visit CooperVision.com to find a Brilliant Futures certified eye doctor near you. Do your patients know what presbyopia is?
There are people who are afraid of the press.
Have you talked to your patients about multifocal contact lenses?
I've heard the bifocal, but not multifocal.
multifocal.
Do you need help with your multifocal strategy? Learn more at the conclusion of this episode.